Once upon a time, there was a Romanian physicist who, if he hadn't published a certain article only in an obscure journal from Iași, would be famous all over the world today. His name is Ștefan Procopiu, and for us Romanians, he is one of the great physicists our country has produced. In 1911, while he was still a student in Iași, he read Pierre Weiss's work. He had just measured for the first time the value of the elementary magnetic moment of the electron, basically, how strong the electron's magnet is when it is at rest, a value called the magneton. Intrigued by the experimental result, Ștefan Procopiu calculated the theoretical value of the magneton for the electron. And in December 1912, he sent the result to the journal Scientific Annals of the University of Iași, where he had just graduated from the Faculty of Science. The article was published in July 1913. In the same month, the much more well-known physicist Niels Bohr also submitted for publication a calculation for the value of the elementary magnetic moment of the electron, obtaining the same value. Bohr's result, as an official well-known at that time, attracted the attention of the scientific world, and researchers named the value the Bohr magneton. Published in a little-known journal, the result of the young Procopiu remained unknown to the scientific world. It's true, I learned in Bucharest about the Bohr-Procopiu magneton, but that's only in Bucharest, where the memory of Procopiu is still alive. Because Ștefan Procopiu did not stop there. He then went to Paris and obtained his doctorate with the physicist M. Coton. Later, he published a paper dedicated to the study of the depolarization of light by liquids containing crystalline particles in suspension. This result is now recognized worldwide as the Procopiu phenomenon. This is how seriousness and persistence eventually yield results. Here are some of Professor Procopiu's words. Because the mission of any university is not only to spread science, but also to create values itself, by inspiring vocations and keeping the sacred fire alive. To the generations that come before it, physicists are travelers in the world, moving from one laboratory to another. Here's an example. The Romanian physicist Eugen Bădărău was born near Galați in 1887. He finished high school in the city of Izmail, today in Ukraine, and already spoke 3 languages at home, Romanian, Russian, and German. In 1905, he attended courses at the Technische Hochschule Graz in Austria, and by 1907 he was pursuing his doctorate at the University of Pisa in Italy. The title of his work is The Dielectric Constant of Gases and Gaseous Mixtures. Between 1915 and 1921, Bădărău was a docent and then a professor at the University of Petrograd. Today's St. Petersburg, where he focused on research in the field of optics, inventing a type of interferometer and studying birefringence in a magnetic field. Amidst the turmoil of the Bolshevik Revolution, he settled in Cernăuți, which had meanwhile become part of Romania, where he became a professor of physics at the university. Here you can see a beautiful picture with the professors of the University of Cernăuți in the years 1923-1924. Among them is also the better-known mathematician Simeon Schumann. In Cernăuți, Eugen Bădărău initiated the first research on the physics of gas discharges in Romania, as the experiments were conducted in Cernăuți at that time. Here is what former students wrote. Professor Bădărău invited all assistants and laboratory preparers to collaborate with him. Each collaborator was assigned to a specific apparatus. The professor at the control desk operated the settings on one apparatus, asking each collaborator to read the data from their own apparatus. Basically, Bădărău would whistle at each change, and at the same time, the data from all the apparatuses would be recorded. In 1935, Eugen Bădărău was transferred to the University of Bucharest, where he continued his career. He took over the Department of Molecular Physics, Acoustics, and Optics. Why can't the elements Dor and Moldavium be found in Mendeleev's periodic table? If a movie were made about a Romanian physicist, the most successful one would clearly be about the life of Horia Hulubei. He is the one who would have given these names. Born in 1996, Horia Hulubei enrolled in the Faculty of Sciences in Iași in 1915. A year later, he was mobilized into the army as a second lieutenant of infantry. He took part in the battles at Namoloasa, where my great-grandfather also fought, and at Mărăcineanu. He becomes a fighter pilot. A projectile sets his plane on fire. He makes a forced landing and is seriously injured. He receives the Legion of Honor from France, and after the war, he is tasked with organizing the civil aviation sector in Romania. Even though he could have had a promising administrative career in high positions, Horia Hulubei did not continue. His love for physico-chemical studies, interrupted by the war, speaks for itself. As an ordinary student, he resumes his studies at the Faculty of Physico-Chemical Sciences in Iași. In the year 1927, we find him as a doctoral student in Paris with Professor Jean Perrin, Nobel Prize winner in 1926 for Brownian motion, collaborating there as well with the famous Marie Curie. He builds a new X-ray laboratory together with Yvette Cochot, improves the X-ray spectroscopy device by using a curved crystal plate. This allows them to study new phenomena such as the double Compton effect, meaning the scattering of X-rays by multiple electrons. Horia Hulubei and Yvette Cochot report spectra indicating the presence of atoms 85, 87, and 93, which had not yet been discovered in nature. Horia Hulubei chooses the word Dor for element 85 and moldavium for element 87. Unfortunately, their effort, made during a difficult period of World War II, is not noticed by the scientific community, which is preoccupied with more serious events. Years later, other authors use new, more precise methods to detect undiscovered atoms. These authors are given both the priority of discovery and the right to name new atoms. Horia Hulubei is elected a member of the French Academy of Sciences in 1940, becomes the rector of the University of Bucharest, and takes a stand against Marshal Antonescu's policy. In February 1944, a memorandum was signed right in his office, demanding Romania's withdrawal from the alliance with Hitler. After August 23, 1944, he was dismissed from his position as rector, arrested, and imprisoned. In the end, he was released following protests from his friends, including the mathematician Simeon Stoilov. In 1949, the new regime tasked Horia Hulubei with establishing a new research institute in physics. This would later become the Institute of Atomic Physics at Măgurele, Trăim. In a world of the internet, but the internet we see today is seen differently by other inhabitants of this planet. When I want to travel virtually and I'm curious about how the world looks in those countries, I use a VPN. Surfshark is a VPN that gives you access to online streaming platforms such as Movix, Com, Azon-E, and others. Surfshark hides your IP address and thus ensures your virtual privacy while browsing the internet. This way, you can search for plane tickets, hotel rooms, and rental cars at lower prices, all this with a minimalist and user-friendly app design. With the Surfshark Alert service, you can receive alerts and benefit from real-time protection, while Surfshark Antivirus helps you keep your device virus-free, perform quick or full scans, benefit from real-time protection, and schedule scans. Visit Surfshark.com Prăjitură and get 4 extra months of Surfshark. Sure, you've heard of the mathematician Gheorghe Țițeica, but have you heard of his son, the physicist Șerban Țițeica? In 1930, he earned his doctorate at the University of Leipzig under the guidance of Werner Heisenberg, the one known for the Heisenberg uncertainty principle in quantum mechanics. It's true, that was a golden age for quantum mechanics. It's no wonder that Șerban Țițeica was acquainted with the well-known physicists Niels Bohr and Peter Debye. His doctoral thesis could only be about quantum mechanics, of course, this time about the quantum theory of metals. Here he establishes a general formula for describing the variation of their resistivity in a magnetic field. He returns to Romania and in 1934 teaches at the University of Bucharest classical experimental physics and later the structure of matter. In 1949, he is appointed full professor at the newly established Department of Theoretical Physics at the University of Bucharest, where he worked for another 36 years until 1977. Here he taught quantum physics, thermodynamics, and statistical and galactic physics, even the theory of the atomic nucleus. Here's a reprinted book on quantum mechanics, which I also have in my library. Besides that, he continued his research in physics on topics such as the energy loss of heavy particles passing through layers of matter, quantum electrodynamics, the study of multipolar electric radiation, and the decay of the pion into a muon and neutrinos, including classical and statistical mechanics topics. Complicanul is just a physicist, a theoretician. Here is what he said about education in the end. There is no education, there is only personal example. Who is the greatest Romanian physicist of all time? For this title, Alexandru Proca would definitely be a candidate, known by all theoreticians in the world for the Proca equations, the ones that bear the name Alexandru Proca. He was an assistant to Professor Vasilescu Carpan at the Polytechnic School of Bucharest. Then he became a student at the Faculty of Sciences at the Sorbonne, where he attended courses of some renowned scientists of the time, Paul Langevin, Jean Perrin, Marcel Briand, and even Marie Curie. In 1925, he became a researcher at Marie Curie's Radium Institute, where he worked on beta radiation, after which he transferred to the Poincaré Institute, where he collaborated with Louis de Broglie. In 1932, Alexandru Proca became director of research and defended a doctoral thesis on Dirac's relativistic theory of the electron. The committee consisted of Jean Perrin, Léon Briand, and Louis de Broglie. What did Proca become known for in 1936? He generalized Maxwell's equations in a vacuum for the case in which the photon, the particle that makes up light, would have a non-zero rest mass, a massive photon. These equations are now known by all theorists in the world as the Proca equations. The massive photon does not exist in nature, but Proca's equations often appear in fundamental physics. I also used them in the book Proca Physics Explained to build a simplified model of elementary particles. Have you heard of artificial rain? A pioneer of this idea is Romanian, like Ștefania Mărăcineanu, who earned her doctorate in Marie Curie's laboratories in France during the interwar period. During her experiments, she needed lead, which she obtained by climbing onto the roof of the Parisian Research Institute where she worked, to her astonishment. She discovered that these samples were partially radioactive and assumed that they had become radioactive under the influence of the sun, but in reality the samples were contaminated with radioactivity. After the numerous rains that fell on the roof of the institute, Ștefania Mărăcineanu made the connection between the rains and radioactivity. Looking closely at how Wilson chambers work for detecting cosmic particles, these are chambers supersaturated with vapors, specially prepared. When a cosmic particle passes through, it ionizes the air, thus generating nucleation centers, on which the water vapor then condenses along the particle's path. It thus leaves a trail in its movement just like airplanes do. Ștefania wondered if the same principle couldn't be used in supersaturated clouds to generate rain. By sprinkling radioactive particles into the clouds, they could condense the vapor and thus generate rain. When, at the end of her doctorate, she returned to the University of Bucharest, she sought the support of the aviator Constantin Cantacuzino, Z, and Bazu. It is said that he used his plane to spread radioactive substances in the clouds and thus generate the first artificial rain, in the year 1931. I doubt this experiment happened, since I haven't found any documents to verify the story. On the other hand, there was interest in the experiment, as a few announcements from the Romanian Academy indicate. It seems that Ștefania Mărăcineanu continued her experiments related to artificial rain in Algeria, with the help of the French government, but without success. However, it's true, I think this method of using radioactive materials is not the most suitable. As for the pilot Constantin Cantacuzino, he also continued his adventurous life, winning several aviation competitions. With the arrival of communism, he became Anna Parker's driver, but then he chose to leave the country together with his wife. Thank you for watching the video until the end, and thanks to the people at Surfshark for sponsoring. Get 4 extra months of Surfshark until next time. I am Christian Presura, Physics Explained. You are awesome and I wish you all the best. Goodbye.